Hello, everybody. Welcome to our last concrete webinar before summer begins. Today, can you hear me? All right. Today's topic is about reinforced and/or prestressed concrete beam. Today's presenters are Lukáš Juříček. Hello, Lukáš.
Hello, Peťa. Hello, everyone. Morning.
And myself, Petra Komárková. Both of us are product engineers, and we mostly work in concrete applications. Before we start with the practical demo, let me remind you that we are using GoToWebinar application. If you have any questions during the webinar, please type them into the questions pane, and I'm going to try to answer them. And if I miss something, I will definitely send you the answer via email. So that's all for my side for the introduction, and let's move to the practical demo. So Lukáš, it's yours.
Thank you. I will take it over. So, hope you will see my presentation in the full screen. Can you confirm it, please?
Yes, we do.
Okay, great. So, today's topic is focused on the beam link and design of the concrete members. We will show it up between SCIA engineer. We will use a global model. After that, we will export the whole global model to StatiCa BIM, do the code check of reinforced concrete section, and after that, we will export it to STATICA BIM, where we will finish it with the design of pretensioned concrete beam. So let's go in. I have launched SCIA Engineer. Now you can see a global model. It's a frame model. The beams are released at the beginnings and at the end. There are hinges. The columns are fixed to the ground. And from the point of view of the loads, I consider dead load, some superimposed dead load. From the point of view of the variable loads, snow and wind from the left and the right side. I have automatically created the combinations for ULS and SLS from characteristic and quasi-permanent, and we will work with these combinations which has been generated in the SCIA engineer. At first, we have to export the structure to STATICA BIM. So I will run linear analysis to obtain results, internal forces from load cases and the load combinations. Yeah, it was very quickly. And for the export, it's important to use XML file. So I will go through the tab tools, XML documents, the window pop up, and I will delete all tabs or all rows in the left part of the window. So I will delete it. click on the default again, and load the template. If you load the template, so it's automatically transferred to the folder where you will find some TDX formats. For previous versions of SCIA Engineer has been used IDEA Import Designer 2014, but for actual version we are using IDEA Import Designer 2020 TDX, right? So I will use it. Now is the process of the regeneration of the document, and yeah, we have a list with the notes, elements, and notes, elements, and internal forces. This is what we need, and use export. I will download the project or this XML file on my desktop and launch export button. So it will take a few seconds, and yeah, the process has been finished, and we obtained the XML file. It's only some viewer. So I close it, and that was the whole process what you have to do in the SCIA Engineer. So I can close it, run IDEA StatiCa version 21, and I change the language to English, close it and run again. And we will use the import. If you would like to export or import some format from the SCIA, you have to use this tab or this button, import, and change the name. You can see we support Axis VM, Midas Civil, and SCIA Engineer for the export to IDEA StatiCa BIM. So I have selected and find my desired XML file and open it. Now all the internal forces and load combinations are exported with the geometry to IDEA StatiCa BIM. This dialog drive me that I can connect all horizontal members to one dimension member. I can do it. It's really cool benefit for design. And also I will try to connect the vertical members to design members. It's for column because I would like to do the design in the one step for all columns. So confirm it, and we'll wait on the geometry. You can see absolutely the same geometry as in the SCIA Engineer. If I change the group, you can see I have sorted out the vertical and the horizontal members to 5 groups, and the members which has same length and same cross section are put it to one design group. Okay. Now it's time. To see the internal forces. If I click on the internal forces, select the group DG2. These are my beams which I would like to code check and see the wireframe. I can see some envelope from ultimate limit state and control the forces with SCIA Engineer. Okay, At first, we will go to the load groups, where we can check that all load cases are sorted correctly. So I mean dead load and superimposed dead load to permanent. Snow is a standard type but variable, and wind from the left and the right side is exclusive because I can't combine it between themselves. So it's correct. If I click on the combinations, you can see the same combinations as in the SCIA has been exported to IDEA, ULS, SLS for quasi-permanent and the characteristic combinations. You can see that the evaluation is according to code. This is the reason why only coefficient 1 is here, and it means that we are using the code partial factors, right? And the final tab is the result classes. What is not in the result classes won't be code checked, right? So ULS, SLS, the same approach as for the combinations. You can see I have it in the middle column, so everything is fine, clear. So I can go to the design immediately. So go to the data tab, and at first, as a default for ultimate limit state and serviceability limit state are all ticked, and the deflections also will be calculated because we would like to know deflection. We are calculating the nonlinear deflection with the decreasing of the stiffness after cracking of the beam, but we don't want to do the code check of the lateral stability because it's a reinforced concrete membrane section. It's not pre-stressed, so it's not important to do the code check of the lateral stability. From the point of view of the exposure classes, I don't consider chlorides, and I will consider XC1 carbonation, dry or permanently wet. Now everything is set. I can move to reinforcement. You can see that the internal algorithm has split the beam to many zones, but I would like to do the code check of the zone C. The beams are symmetrical and are stored on the hinges, so I will do the code check only on the left beam. So the other code checks won't be done. So I can delete it or turn it off, these code checks. I will use some division. Division, it means if standardly or as a default, we are using division 1. It means that after calculation, you obtain the results, the maximal results on the all zone. But I would like to know the maximal utilization in after 1 meter, let's say. So I will split it to the 10 subzones or something like that. Now I will click on the CC section and put the reinforcement. If you are using some cross section from our library, some parametric templates can be used. If not, you have to do it on your own, but I have predefined some template. So via import the reinforcement, I will use reinforcement.nav. It's some text file with the predefined coordinates and the geometry of the reinforced bars. So I have reinforced the section, and I can continue to the code check. If you would like to know some summary overview, just click on the results, but I would like to know what is happening on the cross section. So run detailed analysis. It means that all forces are transferred to IDEA StatiCa RCS. You can see the beam was internally splitted to the 10 zones after approximately 1 meter, and I can run the analysis. I will obtain immediately the results on every zone or every subzone, and we'll know what is happening on the cross section and what I have to do with the cross section. So it should take a few seconds, and you can see that we have a utilization in every zone, but we will check what is happening at first in the middle of the span. So in the middle of the span, it's zone 6, and I can see the capacity is over, and also the stress limitation. So I will sort it out, the value from the maximal to the minimal, and I can check all results here. But if I would like to know more about it, go to the results. I will go to the results, and I can see that the maximal value is for interaction, but at first I will check a stress limitation. And from the point of view of the stress limitation, you can see that the maximum value is for reinforcement rebars. So I should put some additional reinforcement to repair this, to fix this stress limitation code check. Also the capacity, if I check it, I am out of the diagram. So I can go back to the section and check the other. From the point of view of the stress limitation, and also I have to use some additional reinforcement for that. But from my point of view, so there is a really high value which I have to cover. So it's time to put some prestressed tendons, because I don't have an option from the stage of the project. I don't have an option to change the cross section, and some additional reinforcement don't help me so much. So it's time to create some prestressed tendons. So what I have to do now, so I can go back to STATICA beam. Yeah, I forgot the deflection calculation. So at first you can see that the reinforcement is not enough, but what about the deflection? In the deflection code check, we have some limits according to Eurocode. Some as a default is code check according to chapter 7.4.1, but we have some restrictions, and we have to use the limitations ratio length divided by 500, because we have to use small, or small deflections are important here. So this code check is offering on me. Now I will run the analysis to obtain the deflection code check, and also the other code checks. So Petty, I think now it's time to launch the poll.
All right, Lukim. So let me launch it. So We have prepared one question for you. I hope you can see it. The question is, what is your typical workflow at design and check of reinforced and pre-stressed concrete structures? Please choose only one answer that best describes your workflow. The first option is analyzing of only isolated members via simple tools. Means you design and co-check, for example, beam, columns, frames, and using tools like StatiCa beam, column, Corbel, other software like Fin, Freelaw, RIP, etc. The second option is creating 3D finite element model and analyze it in FEA software, but the code checks are performed elsewhere, like StatiCa, for example. The third option is that you model 3D, you create 3D model in FEA, analyze it there, and also check it here. So you are using built-in checks. And the fourth option is the combination of 3D modeling in FEA and using simple tools, depending on your project, if it's simple or too complex. So I will let you vote for a few more seconds. And I think, okay, so I'm gonna stop it and share the results. So thank you for your voting. It's quite interesting that none of the option is dominant, so it is equally balanced. So I'm quite surprised, but we really like your voting, and it helps us to improve our existing applications. So, okay, so we have like 3 winners. So basically 3D modeling and combination is the typical workflow for you. All right, so thank you for the voting again, and I'm passing the floor, Lukáš. Right.
Thank you, Petty. I will take. Hope you will see my screen again. Okay. So the process of the calculation has been finished, and we've got the results. You can see it's a summary overview of the all results with the maximal values of the utilization. And from the point of view of the deflection check, we can see that we have a deformed shape. If we click on the deflection check, and we can see the maximal value, it's in the middle of the span, it's a 53 millimeters, but it's over the limit. So we have to design some pretension tendons to reduce the deflection on the beam. So this is the second issue on the beam which we have to resolve, and I hope we will do it through the tendons. So come back to the design member, and in the design member, if I select some solid view, I would like to export only the left beam because it's a symmetrical beam which are stored on the hinges. So we will export only this beam. How to do that? We will turn on the members 1D, and you can see that the member it's named B4, B142, and B5. So at first, I will create a design member, name, address the name, it's export, and select the members. So B4, double click on it, B5, and B142. 42. Now it's fine. Okay. But you can see actually right now I don't have an option to export it. To the button is being available if you create a design group. So create a new design group and select the member type. I will use a beam and export my design member export. You can see now it's available, and we can export the beam to the application StatiCa beam. So at first I have to download the project, call it export, and now is the process of preparing the data for the beam. I have to again create boundary conditions. It's a simply supported beam, so it's a fixed hinge, and here is some sliding hinge. I know that my load is only in the vertical plane, so I can let it straight beam load it in the vertical plane, and don't have to use the option in the 3D. It's more complicated, so I can let it as a 2D. I have selected some procedure, prefabricated concrete beam, which will be pre-stressed precast beam with the option of the subsequent post-tensioning. We will do on the next step, and select some national annexes. You can see we have a really rich library. Design working life is 50 years, and the self-weight will be calculated according to the cross sections, and all additional loads won't be considered. We will export it from the beam and from the created combinations in the SCIA engineer. So no critical load patterns. I can let it like this and move to the next step, where is the selection of the load cases. If I turn it off, this tick, I can export or select what load cases will be exported to the beam. So from my point of view, dead load is calculated from the cross section, so only these 4. So edit and continue. Now it's time to create construction stage. At first stage of pre-stressing, I will select PRE. It means pre-tensioning. All the other subsequent post-tensioning won't be considered, so I let it empty. And the distance in every construction stages for storage yard and transport will be 2 meters from the beginning and the end of the beam. So you can see it's automatically filling out to all gaps, and the final supports will be to the correct position. I can let the timing for construction stages, it's fine, it's suitable for me, and continue to finish. Now all the data are exporting to the beam, all the geometry, and you can see how it looks. This is my beam, my supports, my static scheme. I can continue to load cases, and in the load cases, you can see I have some superimposed dead load, snow, wind, and wind right, but no loads. What is happening? If you are using the export, all the internal force are exported, only the internal forces, no loads. So it means I have to use user-defined forces to check if the shape of the internal forces is correct. So I click on the internal forces, and let's select the snow. And if I click on it, you can see I will receive some bending moment from the load of the snow. So here I can check the values. I can come back to the load cases, and in the load cases At first, we will start with the permanent loads. You can see that the superimposed dead load, it's not sorted to construction stages. So it's time to do it. So go to the construction stages, to the superimposed dead load, and I can use load cases or load combinations for addition to this stage. So use the pen, double click, and everything is corrected. Update the combinations, and I can go back to the load cases. You can see now the superimposed dead load is sorted out to construction stage number 6, and now it's time to prepare some pressure factors for snow and the wind. So go to the variable load groups, and I will address the name. It's snow, and the second load case will be wind. The snow will be considered in the combinations as a standard. It means it combined in every combinations with the other load cases, but the wind will be considered as exclusive. It means wind from the left side cannot be combined with the wind on the right side. And now it's time to change the pressure factors, P0, P1, and P2. For snow, it's as a default, and for wind, I will change it. It's 0.6, 0.3, and a 0. Now I can come back to the load cases, and I will add the type to the load group. So snow, I can let it and change the wind only. Now everything is prepared for the combinations. So I can come back to the combination, go to the edit button, because the internal generator of the combination will generate all necessary combinations, but we have to say the software where to put variable loads, because he doesn't know. So I would like to use some variable loads to superimpose that load case, and also to the end of the design working life. So I will select it only and shift it to the middle column for all combinations for service reliability limit state and ultimate limit state. Yeah, it's take a really small time. Okay, see, I finished. Update the combinations, but what we forgot the tendons. So if I would like to design the tendons, on the ribbon is tendon design. So now the external module for designing pre-tension tendons is starting, and we will design pre-tension tendons. So we can skip the design members and jump to tendon layout. Now we can check how the geometry looks in the 3D, some isometry, and you have two options if you would like to design the tendons which are pretensioned. We can use pretension on the edge or pretension in the line. These are two options. I have predefined the templates, so we will use the import and upload the tendons. You can see these are only straight tendons, so it's really easy geometry. So I could do it by using pretension on the edge or pretension in the line. Yeah, but if you have some complicated geometry of the tendons, let's say for post-tension tendons, it's better to use the import of the geometry. But for really easy geometry, it's more suitable to use pretension on the edge. But I have used the import. If you put the tendons, you have to select materials, which is used as a default is Y 1860 S7 with a diameter of the strand 15.7. We have a really massive library of the tendons from the point of view of the class, and you can select it. And if you don't find, you can create your own. What is really important for pre-stressing is initial stress. Here is the value is calculated as a default from the class of the material. It's a maximal value, but you can change it. If you have lower or not higher but lower value of initial stress, you can put it here. But we would like to utilize the tendons on the maximum, so we can let it. Now we have 3 tendons in a row, but we don't know if the linear stress in the stage of pre-stressing is so huge that the top fibers will reach over the tensile strength of the concrete. We have to cover that. So we have 2 tools for force design or for pretension force design: equivalent load option or linear stress. If I will run linear stress on the cross section, I will obtain some envelope of the stresses, and I immediately know if the cross section can transfer the load or not. And it's some pre-design which is really important for the engineer. So I have to select what combinations I would like to check. So I would like to check only construction stage number 2, and it's a pre-stressing. So I can remove the end of the design working life, and I can run the analysis. I have concrete grade C30/37, where the maximal strength in the tension is approximately 3 megapascals. So I'm on the limit from the point of view of the tensile strength, but the concrete cross sections won't be cracked at this stage. The maximal strength or the maximal stress in compression is -10, and in the tension 2.9. So 3 tendons are enough for this stage, and we can continue to the design, to the pre-stressing losses calculation. You can also add some other stage, let's say at the end of design working life, if you want to have some compression or decompression zone on the cross section. So I can also check the end of the design working life, and I will know what is happening. You can see I have at the end of the design working life, there is a tensile strength 6.1 megapascal. It means the section will be cracked at this stage, but we have also some reinforcement rebars, so it's not a problem for some exposure classes. We will run a tendon analysis for the long-term and the short-term losses, and you can see what happened. I have some blanketed length at the end and at the beginning of the beam, so it means the stress is getting increased from the distance 1.2 meter from the left edge, and I have some linear increasing of the stress, and my transmission zone is 1.26 meters to maximal value of the stress. The red line represents the stress after releasing, and also the blue line is stress after long-term losses. If I would like to know more about it, more about losses, all losses are tabled in this list. I have some encourage set loss, some loss due to difference in the temperature of pre-stressing steel and stressing bed. And sigma PA is stress after short-term losses. So you can see I have sorted out the value along the length of the beam. These are short-term stress, the stress after short-term losses, and in the bottom table are presented the losses from the creep and the shrinkage, and also the long-term relaxation. And this is my final stress at the end of the design working life, yeah, after all losses. So it was or it's regarding to losses on the tendons, and we can come back to the STatiCa beam and go to the settings. In the settings, it's really important to set correctly end of the curing. I will set it on the 5-day because it's the time of the pre-stressing and it's the time when the shrinkage will be considered. Also, we have a feature calculation of the nonlinear creep. It's really useful to turn it on because it help you with the design and with the code checks if are over the limit. Mainly, this calculation of the nonlinear creep is really helpful for stress limitation from the point of view of the quasi-permanent combination, where the limit is 0.45 times the strength of the concrete for the linear creep. And if I use nonlinear creep, I can use the coefficient 0.6, not 0.45. So it's really helpful. Now we can check the construction stages, what is happening through the construction stages, how the supports are changing. And you can see I can do the code check only for transfer of pre-stressing or end of the design working life. I can let it. All the other code checks won't be assessed, and we can go to the internal forces. In the internal forces, I can select what stage I would like to see and what combinations or what load case I would like to see. Yeah, it's pretension, it's a pretension force, it's a bending moment. Here is pretension compression force. So I can display everything I want during the construction stage. Now it's time to go to the data. You can see we will do the same process as in the STatiCa beam. From this point, it's same. So all data for ultimate limit state and serviceability limit state are automatically turned on, and we would like to do some additional code check of the lateral stability. We select only carbonation XC1, do the code check of the combinations, it's important, and we can proceed to reinforcement. You can see that beam was automatically split it to couple zones, but I would like to do the code check only the zone C. Yeah, so all the other cuts can be removed, because if you would like to do the code check of the pretension tendons, there is necessary to use a cut. So I would like to see, or I know that this is a simply supported beam, so the maximal bending moment will be in the middle, and also the maximal shear force will be 0.6 from the point 1. It's a effective width of the section. So now everything is fine, and it's time to put the reinforcement template. Also We will use the import, the same reinforcement. I confirm it, and I can jump to the detailed. Now has been appeared the RCS, or internal forces, has been transferred from the beam. I will run it. And you can see I have very quickly the design, but something is wrong. I have utilization 232%. What is happening? I will check it. If I sort it out from the maximum to the minimum value, click on the value 232%, I can see that the problem is in the shear, but Eurocode is benevolent, and the angle of the compression strut can be changed between the 21.6 till 45, and in the RCS is set as a default 45 degree. So I can release more force from the shear to the longitudinal rebars and less to the stirrups. So go to the results, to the shear, and run the strut optimization. Now we have some internal algorithm which is finding out the most useful angle to all code checks have been passed. Yeah, or have passed, sorry. So it takes only sometimes. We have only 2 sections, and come back to the section and run the analysis again. You can see it now. The maximum utilization is 72%, not 243. Yeah. So this is the way how to change the results. So we will take some seconds for the results, and after that we will see or check the deflection. Yeah. So during the calculation, you can see that also the detailing and all the checks were fulfilled, and we are on the utilization 95% at the middle of this of the span. And I would like to show you some code checks in the application RCS on the tendons. Mainly the stress limitation, because the stress limitation for RC section was over the limit. So we will select the beam or the section in the middle, go to the results, and see the stress limitation. Yeah, you can see this is the stress limitation at the stage of the pre-stressing. You can see we have a tension in the top fibers, 2 megapascals, but it's not cracked. Yeah. And at the end of the design working life, it's cracked, but the maximum utilization is for tendons. And yeah, this is it. So I will close it and run the final calculation to obtain the results of the deflection, and we will check the deflection and the criteria L, the ratio L divided 500. If you are using the calculation of deflection for staged beam, or where the construction staged are developed, you can check the deflection in every stage, and we consider if the concrete section will be cracked in some stage, so we consider some cracked section. So it means the stiffness, like bending stiffness, is getting decreased, and yeah, it will take sometimes, and we will see. We can see at the construction stage analysis, we can see also the increment from the creep, and it's very important because the creep is really marginal coefficient or marginal increment of the deflection, because if you have a simply supported beam, so no redistribution of the internal forces will be developed, but the deflection is getting higher and higher due to the viscous elasticity of the concrete. So now you can see we've got the results of the deflection, and here is some summary overview. We have a deflection 21 millimeters, and the opposite value, which was the peak. It was at the stage of the pre-stressing. We will check it more detailedly. Go to detailed check. I can select what stage I would like to see, so we can see the end of the design working life, and also see the stiffness. You can see that the stiffness is getting decreased to the middle of the beam. It's because it's cracked, right? We can see also some total long-term or immediate deflection, and also the deflection from the point of view of the increment of the creep, and the increment of the creep is 14 millimeters. So it's really big percentage from the total deflection of the beam. So that's it from my side. Thank you for your attention, and I would like to pass presenter to Peťa.
Thank you, Luky. Thank you for your practical demonstration of the workflow, how to switch from reinforced concrete to pre-stressed concrete. Since we are running out of the time, we do not have space for your questions. I selected only one question, which is quite important. One user asked us if we can import or design the pre-stressing in SCIA and then imported it to idea StatiCa, or what is the difference between pre-stressing in SCIA and idea StatiCa. The truth is that we cannot import tendons from SCIA. That's why we import just the geometry and internal forces and design the tendons and pre-stressing in idea StatiCa. This is some kind of limitation of this BIM link. We know about this and we might change it in the future. I can say that only BIM link with Midas products enables importing of pre-stressing or tendons. So the rest of the questions were answered directly in the chat, and I'm sure that I missed something, but don't worry, we will send them via email. What are we preparing? You can definitely look forward for the next webinar at the end of the May. It's the series Connection Wednesday, and we will specify the topic later. And after the webinar, please fill in the short survey and suggest your ideas, experience. There will be a recording in our support center and on YouTube channel in 2 days or 3 days, I think. And if you are newbie and you don't know Idea StatiCa, get the trial version at ideastatica.com. And for all of you, I invite you to our support center where you can look up for interesting case studies, tutorials, and articles about idea StatiCa and what you can design and co-check there. So that's all from us for today. Have a great day and calculate yesterday's estimates.
See you. Bye-bye.
Bye.